Welcome to Science 9, second quarter, week 7, the mole. Our learning objective for this topic is use the mole concept to express the mass of substances. Medicines are chemicals or compounds used to cure, halt, or prevent disease, itch symptoms, or help in the diagnosis of illnesses. Advances in medicines have enabled doctors to cure many diseases and save lives. These days, medicines come from a variety of sources. Many were developed from substances found in nature, and even today, many are extracted from plants. Some medicines are made in labs by mixing together a number of chemicals. Others, like penicillin, are byproducts of organisms, such as fungus, and a few are even biologically engineered by inserting genes into bacteria that make them produce the desired substance. When we think about taking medicines, we often think of pills, but medicines can be delivered in many ways, such as liquids that are swallowed, drops that are put into ears or eyes, creams, gels, or ointments that are rubbed onto the skin, inhalers like nasal sprays or asthma inhalers, patches that are stuck to skin called transdermal patches, tablets that are placed under the tongue called sublingual medicines. The medicines is absorbed into the blood cells and enter the bloodstream, and injections or shots or intravenous inserted into vein medicines. But how do we form the rightful amount of medicine that we need? To medicines, plastics, and even burning pieces of wood require amount of substances that will produce one. But how do we measure those small entities? All these examples have involved using the concept mole or moles. In this lesson, we will be able to understand the mole concept and Avogadro's number. Also, we will be able to learn conversion among moles, mass, and the number of atoms in a given sample. The mole is an amount unit similar to a familiar units like pair, dozen, gross, etc. It provides a specific measure of the number of atoms or molecules in a bulk sample of matter. A mole is defined as the amount of substance containing the same number of discrete entities such as atoms, molecules, and ions as the number of atoms in a sample of pure 12 carbon weighing exactly 12 grams. Avogadro's number is the number of particles in 1 mole of substance in honor of Italian scientist Amedeo Avogadro. It is a very large number equal to 6.022 times 10 raised to 23 particles. So, a mole or 1 mole of a substance is equal to 6.022 times 10 raised to 23 representative particles of that substance. The representative particles can be atoms, molecules, or formula units. So, 1 mole of a substance is always equal to 6.022 times 10 raised to 23 particles, and that particles could be molecule, atoms, or formula units. So, 1 mole of carbon-12 contains 6.022 times 10 raised to 23 atoms. 1 mole of water contains 6.022 times 10 raised to 23 water molecules. And 1 mole of sodium chloride or the table salt contains 6.022 times 10 raised to 23 formula units of sodium chloride. Example: how many molecules are present in 4.04 mole of carbon dioxide? We all know that every 1 mole of carbon dioxide that is always equal to 6.022 times 10 raised to 23 molecules. But the question here is, how many molecules are there in 4 moles of carbon dioxide? So to get that 4 mole of carbon dioxide, we have to multiply it to, in every 1 mole of carbon dioxide, there is 6.022 times 10 raised to 23 molecules. So what you're going to do is you have to multiply 4.0 mole of carbon dioxide to 6.022 times 10 raised to 23 molecules and divide it by 1 mole of carbon dioxide. So once we do it, we can cancel some unit. Okay. So to make it simpler, just multiply 4 times 6.022 times 10 raised to 23 molecules. Okay, so this is in scientific notation, so what it is very advisable to use scientific calculator to do it. Okay, 4.0 times 6.022 times 10 raised to 23. Okay, okay na tong di na i-divide sa 1 because any number divided by 1 is still that's the number. Okay, so 4.0 times 6.022 times 10 raised to 23 is, that's 2.41 times 10 raised to 24 molecules of carbon dioxide. So, ibig sabihin, there is 2.41 times 10 raised to 24 molecules of carbon dioxide in 4.04 mole of carbon dioxide. Another example, how many molecules are present in 2.76 mole of water? Always remember, in every 1 mole of substance, like in every 1 mole of water, there's always 6.022 times 10 raised to 23 molecules of water. So, to get the number of molecules in 2.76 moles, okay, we have to write 2.76 mole of water times, in every 1 mole of water, there is always equal to 6.022 times 10 raised to 20 molecules of water. So cancel the unit. Okay. So 2.76 times 6.022 times 23 molecules is, the answer is 1.66 times 10 raised to 24 molecules of water. So it is advisable to use scientific calculator to multiply 2.76 times 6.022 times 10 raised to 23 molecules, because this is in scientific notation. It should be enclosed in parentheses before it is multiplied to 2.76. Okay, so scientific calculator is advisable to do it. So the answer is 1.66 times 10 raised to 24 molecules of water. So in 2.76 mole of water, there is 1.66 times 10 raised to 24 molecules of water. Another example is that how many molecules are present in 2.509 moles of hydrogen sulfide? So 2.509 mole of hydrogen sulfide. In every 1 mole of hydrogen sulfide, there is 6.022 times 10 raised to 23 molecules of hydrogen sulfide. Okay, cancel ang unit. Just multiply 2.509 times 6.022 times 10 raised to 23. The number of molecules of hydrogen sulfide in 2.509 mole of hydrogen sulfide is 1.51 times 10 raised to 24 molecules of hydrogen sulfide. So again, in 2.509 mole of hydrogen sulfide, there is 1.51 times 10 raised to 24 molecules of hydrogen sulfide. Calculating moles from a given mass. How can we calculate number of moles if the given is the mass of that substance? Example, an aluminum, a metal with a high strength to weight ratio and high resistance to corrosion, is often used for structures such as high quality bicycle frames. Compute for the number of moles in 8.0 grams sample of aluminum. So what we're going to do is to identify the number of moles. Okay, the number of moles in a given mass. Okay, so on the previous slide, given a mole, we are asking for the number of molecule, but this time, where we were looking for the number of moles from the given mass of a substance, like 8.0 gram of aluminum. We have to get the number of mole in an 8.0 gram of aluminum. Compute for the number of moles in 8.0 gram sample of aluminum. How to get that? We have to always reminded about the atomic mass of the aluminum. The atomic mass of aluminum is 26.98158, okay, atomic mass unit or gram per mole. So since we're looking for the number of moles in a given mass of a substance, we have to get the mass of that element, of that given element first. Okay, its atomic mass or the molar mass of that substance for us to be able to get the mole of that substance in the given mass of the substance in the problem. Okay, so if the given if the problem is looking for the number of mole, and we are looking for the and from the mass of in the problem, we have to take a look on the atomic mass of the element or the compound to get the number of moles on that given mass. So it is very important to take note the atomic mass of the element of that substance. For that reason, I show to you the atomic mass of the aluminum because that's the substance we are um, we are tackling in the problem. Okay, so in 1 mole of aluminum, there is 26.98 grams of aluminum. Where did I get this one? From its atomic mass, 26.98. So I just rounded off na lang until to the second or to the 10th decimal places or 2 decimal places. Okay? So, I mean hundreds place. I mean pala, hundreds place or 2 decimal places. So, in every 1 mole of aluminum, there is always 26.98 gram of aluminum. Again, comes from the atomic mass of the aluminum. Okay? So, 8.0 gram of aluminum, this 8.80 gram of the aluminum is the given on the problem. Okay? And we will use the atomic mass of the aluminum and to get the number of moles of aluminum from this mass of aluminum in this problem. So to get that 8.0 gram of aluminum, multiplied it to in every 1 mole of aluminum, there is always 26.98 gram of aluminum. So, saan to galing? Ito po yun. Dito po galing yon, and 26.98 gram of aluminum comes from the atomic mass of the aluminum. Okay? So, what we're going to do is 8.0 gram of aluminum times 1 divided by 26.98. Or you're just going directly to make it simpler, 8.008 divided by 26.98. Okay, so once we do it, we can now cancel some unit. Okay, we can cancel gram. Okay, we can now cancel gram at ang matitirang unit ay mole. And ito yung hinahanap nating unit, yung mole. Okay, so 8.0 times 1 divided by 26.98, or directly 8.0 divided by 26.98, the answer will be 0.297 mole of aluminum. That's the answer. So, ibig sabihin, in 8.0 gram of aluminum, there is 0.297 mole of aluminum. Another example, lithium. How many moles are in 15 grams of lithium? So since the problem, the given is the mass, we're looking for the number of moles on the given mass. Always take a look at the atomic mass of the lithium. Okay? The atomic mass of the lithium is 6.941. So in every 1 mole of lithium, there is 6941 gram of lithium. Okay, saan to galing ulit? Sa atomic mass ng lithium. Because it says here, the atomic mass of lithium is 6.941 gram per mole. So, what does it mean? In every 1 mole of lithium, there is 6.941 gram of lithium. So, we can now use this one to solve this problem. So, 15 grams of lithium times in every 1 mole of lithium, there is how many grams? There is 6.941 gram of lithium. We have, so what we're going to do is just 15.0 times 1 divided by 6.941, or directly 15.0 divided by 6.941. So once we do it, we can now cancel some unit. That's the gram. Okay, so 15.0 divided by 6.941, the answer is 2.16 mole of lithium. So meaning to say, in 15 grams of lithium, there is 2.16 mole of lithium. Another example, sulfur. How many moles are in 77 grams of sulfur? Sulfur, its atomic mass is 32.065 gram per mole. So what does it mean? In every 1 mole of sulfur, there is 32.065 gram of sulfur. So 77 grams of sulfur times in every 1 mole of sulfur, there is 32.065 grams of sulfur. So what we're going to do is we have to divide 77 grams to 32.065 grams of sulfur. So once we do it, we can now cancel some unit. Okay, so 77 divided by 32.065, that's the direct. Pero the longer operation is that 77 times 1 divided by 32. Or to make it easier, directly 77 divided by 32.065, the answer is 2.40 mole of sulfur. So in 77 grams of sulfur, there is 2.40 mole of sulfur. For your week task for week 7, what you're going to do is to answer learning tasks 1 and 3 found on page 37 of your second quarter module in science, and do your performance task for week 7, the mole challenge direction. Complete the following, show your solution, write your answer on a clean sheet of paper. Number 1, silver, the white metal, has an illustrious reputation for its use in jewelry and coins, but today, silver's primary use is industrial. 1 mole of silver is equal to 107.87 grams of silver. The question is, how many numbers of moles are there in 38 grams of silver? Okay, so how many moles are there in 38 grams of silver, wherein in every 1 mole of silver there is equal to 107.87 grams of silver. Number 2, copper is widely used due to its ductility and electrical and thermal conductivity. It is oftentimes used in the production of electrical conductors, switches, transformers, and telecommunications. 1 mole of copper is equal to 63.55 grams of copper. The question is, how many number of moles are there in 50.1 grams of copper? So the question for number 2 is, how many number of moles, or how many moles are there in 50.1 grams of copper, wherein in every 1 mole of copper there is equal to 63.55 grams of copper. Calculating moles and number of atoms. So we know this one. Okay, aluminum, another example using the substance aluminum, but this time what we're going to do is from the mole. Okay, we computed, we have to get the number of atoms. So aluminum, a metal with a high strength to weight ratio and a high resistance to corrosion, is often used for structures such as high-quality bicycle frames. So this time, compute both the number of moles of atoms and the number of atoms in 10.0 gram of sample. So this time, 10.0 gram sample of aluminum. So we have to get the number of moles on that 10-gram sample of aluminum and the number of atoms from the moles computed from the 10-gram sample of aluminum. Okay, so compute both the number of moles and of atoms, the number of atoms in 10 gram sample of aluminum. So what we're going to do is, the given is 10 gram of aluminum. So what we're going to do is the number of moles of aluminum atoms. Okay. So in every 1 mole of aluminum, we are already oriented with this one from the previous slide. There is 26.98 gram of aluminum. Okay, so compute for the number of moles of atoms and number of atoms in 10 grams of aluminum. So again, 1 mole of aluminum is 26.98 grams of aluminum. Okay, so in every 1 mole of aluminum, there is 26.98 grams of aluminum. So cancel the gram. What we're going to do is divide 10 divided by 26.98. The answer is 0.371 mole of aluminum. So meaning to say, in 10 grams of aluminum, there is 0.37 mole of aluminum. We already get the number of moles of the atoms. Another requirement is we're looking for the number of atoms in that given sample. So we can now use this one. We can now use the computed number of moles to get the number of atoms. Okay, how to get that? So using this one, 0.37 mole of aluminum. So ito ay galing dun sa kasagot natin na mole. Since we are looking for, aside from the moles, we are looking for the number of atoms. So hindi pa tapos ang ating solution. So mole pa lang nakukuha natin kasi nakalagay and the number of atoms. So we are also looking for the number of atoms. We will use the computed number of moles to get the number of atoms. The computed number of moles is 0.371 mole of aluminum. Okay, so 0.37 mole of aluminum times, in every 1 mole of aluminum, again, there is 26.98 gram of aluminum. Or, I mean, let us again repeat, in every 1 mole of aluminum, how many atoms? Okay, so let us take a look again, take back, reminded again, or let us recall the number of atoms or molecules in 1 mole of substance. In every 1 mole of aluminum, how many molecules, atoms, or formula units? There is always equal to 6.022 times 10 raised to 23 atoms. Since we're looking for the number of atoms, ibabaguhin natin to, instead of molecules, we have to write atoms. So, pwede naman siyang maging atoms ang kanyang unit. Bakit ganito na? Kasi we're looking now for the number of atoms. So in every 1 mole of aluminum, there is always equal to 6.022 times 10 raised to 23 atoms. Okay? So the unit will be cancelled. So what we're going to do is that 0.371 times 6.022 times 10 raised to 23. Okay na kung hindi na i-divide sa 1 kasi any number divided by 1, that's kasi the same pa rin naman yung answer. So 0.371 times 6.022 times 10 raised to 23 is, that's 2.23 times 10 raised to 23 atoms of aluminum. Okay, so meaning to say, in a 10 gram sample of aluminum, how many moles? 0.371 mole of aluminum. How many number of atoms? There is 2.23 times 10 raised to 23 atoms of aluminum. Calculating molar mass of a compound. The atomic mass of an element is the number of grams in 1 mole of atoms of that element, while the molecular mass of a compound is the number of grams in 1 mole of molecules of that compound. Sometimes these masses are called molar masses to emphasize the fact that they are the mass of 1 mole of things. So molar mass is the mass of one substance in grams. If you still remember the atomic mass, we use the atomic mass to get the mass of a certain substance in 1 mole of that substance. So the atomic mass of the element is the number of grams in 1 mole of atoms of that element. Okay, what's the mass of 1 mole of gold? That's the 196.96 gram per mole. Okay, so meaning to say, the mass of gold, that's the atomic mass of gold. Okay, so where can you get the atomic mass of a certain element on the periodic table of elements? The atomic mass of gold is 196.96 gram. So meaning to say, in every 1 mole of gold, there is 196 0.96 gram of aluminum. I mean, of gold. That's AU. Okay? So that's the ano. What's the mass of 1 mole of potassium? So potassium, its atomic mass is 39.10 grams per mole. So meaning to say, in 1 mole of potassium, there is 39.10 grams of potassium. That's the mass of potassium in every 1 mole of potassium. Where did we get this 39.10? There we get this 39.10 on the atomic mass of potassium. We can see it, or we can see those atomic masses on the periodic table of elements. So meaning to say, the atomic mass of a certain element, that's the mass of the element in every 1 mole of that element. Okay? We have molar mass. While the molecular mass of a compound is the number of grams in 1 mole of molecules of that compound, sometimes these masses are called molar masses. To emphasize that fact that they are the mass of 1 mole of things, molar mass is the mass of one substance in grams. In the previous slide, we discussed it by elements. Okay, but this time compound. How can we get the mass of that compound? We will use the term molar masses. Okay, so that's the molar mass. We can in identifying the molar mass of a certain compound, we have to use also, or we still use the atomic masses of the element on that compound. Okay, how to do it? Example, what is the molar mass of 1 mole of hydrogen gas? In hydrogen gas, there is 2 hydrogen. Okay, how to get the molar mass of hydrogen gas? So this is not totally an element but a compound because it has already 2 hydrogen. So it's already a molecule or compound. Okay, so what's the molar mass? What's the mass of 1 mole of hydrogen gas? Since hydrogen, its atomic mass is 1.01 grams per mole. Okay? So, ang 1.01 gram per mole, that's the atomic mass of hydrogen. At yun ay makikita sa periodic table of elements. But since in hydrogen gas, that's H2, we have 2 hydrogen. So, 1.01 gram per mole, we have to multiply it by 2. Okay? To get the molar mass of H2 or hydrogen gas. Bakit may multiply sa 2? Kasi dalawa yung H sa hydrogen gas. So, may multiply natin yung atomic mass ng H na hydrogen into 2 to get the molar mass of hydrogen gas. Okay, so 2 times 1.01 gram per mole, the molar mass of hydrogen gas or H2 is 2.02 gram per mole. Another example is that what's the molar mass of 1 mole of H2O? Okay, how to get that? So we can now use some table to make it to further explain how to get it. Okay, so in H2O, we have 2 elements, the hydrogen and oxygen. Okay, how many atoms of hydrogen are there in the water or is there in water molecule? So, nakalagay H2O, so meaning to say there is 2 atom of hydrogen in water molecule or H2O. May dalawang H sa H2O. Okay, ilan naman how many atoms of oxygen is there in water or H2O? There is only 1. Okay, what's the atomic mass of hydrogen? It is already mentioned that the atomic mass of hydrogen is 1.01 gram per mole. Where can we get the atomic mass? We can take a look these atomic masses on the periodic table of elements. The atomic masses of every element is written on the periodic table of elements. Okay, how about the oxygen? Okay, so before that, before we get we take a look at the atomic mass of oxygen, let us now first compute. So 2 times 1.0 gram per mole, that's 2.02 gram per mole. Okay, kasi kaya itong atomic mass na ito multiply sa 2 kasi dalawa yung hydrogen sa water. So we have to multiply the 2. Okay? So meaning to say the atomic masses in a certain molecule or compound, we have to multiply the number of atoms of that element on that compound to its atomic mass. Then, para makuha yung molar mass ng compound or molecule na yun. So, we multiplied 1.01, that's atomic mass of hydrogen, to 2 because in water or H2O, there is 2 hydrogen. So, 2 times 1.01, that's 2.02. What's the atomic mass of oxygen? Based on the periodic table of elements, the atomic mass of oxygen is 16.00. So, 16.00 times 1, the answer is 16.00 gram per mole. So what we're going to do here is that we have to add this 2.02 grams per mole plus 6.00 gram per mole. The answer is 18.02 gram per mole. That's the molar mass of 1 mole of water. So the molar mass of 1 mole of H2O or water is 18.02 gram per mole. Another example, what's the molar mass of CH4? In this molecule, there are two elements. We have carbon and hydrogen. The number of atoms of carbon in CH4 is only 1. The number of atoms of H or hydrogen in CH4 is 4. The atomic mass of carbon is 12.01 gram per mole. So where can we get that? So this atomic mass is given on the periodic table of elements. So 1 times 12.1 or 12.01, the answer is 12.001 gram per mole. How about hydrogen? What's the atomic mass of hydrogen? Based on the periodic table of elements, the atomic mass of hydrogen is 1.008 gram per mole or 1.01 okay, before. So, but it is extended 1.008 gram per mole. Okay? So 1.008 gram per mole times 4 kasi in CH4 there is 4 H atoms, so we have to multiply its atomic mass to 4. So 1.008 times 4, that's 4.032 gram per mole. Anong gagawin dito? 12.01 gram per mole plus 4.032 gram per mole. The answer is 16.04 gram per mole. So that is the molar mass. 16.04 gram per mole is the molar mass of CH4. Another example is, what's the molar mass of SO2? In this problem, there are two sample, or there are two elements. We have sulfur and oxygen. The number of atoms of sulfur is 1. The number of atoms of oxygen in the molecule of SO2 is 2. The atomic mass of sulfur is 32.07. Therefore, 32.07 times 1 is 32.07 gram per mole. The number of the atomic mass of oxygen based on the periodic table of element is 16.00. So 2 times 16.00, the answer is 32.00 gram per mole. So 32.07 gram per mole plus 32.00 is 64.0 gram per mole. That's the molar mass of SO. Another example is, what's the molar mass of sodium carbonate? In sodium carbonate, there are three elements. We have sodium, carbon, and oxygen. The number of atoms of sodium is, or let us take a look first, its atomic mass. The atomic mass of sodium is 23. The carbon is 12.01 and the oxygen is 6.00 gram per mole. How many atoms of sodium are there in sodium carbonate? That's correct. That's 2. How many atoms of carbon are there in sodium carbonate? There's only 1. How many atoms of oxygen are there in sodium carbonate? That is 3. So 2 times 23, the answer is 46.0 gram per mole. 1 times 12.01, the answer is 12.01 gram per mole. And 3 times 16.00 gram per mole is 96.00 gram per mole. So from this one, you have to add this atomic masses, okay, to get the molar mass of sodium carbonate. So 4.60 plus 12.01 plus 96.00, the answer is 106.01 gram per mole. That's the molar mass of sodium carbonate. How about the molar mass of glucose? C6H12O6 is a glucose. That's an example of organic compound, which is a type of carbohydrates. In 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 glucose, there are three elements. We have carbon, hydrogen, and oxygen. The atomic mass of carbon is 12.01. The atomic mass of hydrogen is 1.01, and the atomic mass of oxygen is 16.00. The number of atoms of carbon in glucose is 6. The number of atoms of hydrogen in glucose is 12. The number of atoms in oxygen in glucose is 6. Okay, 6. So therefore, 6 times 12.01, the answer is 72.06 gram per mole. 12 times 1.01, the answer is 12.12 gram per mole. 6 times 16.00, the answer is 96.00 gram per mole. So, what will be now the sum 72.06 gram per mole plus 12.12 gram per mole plus 96.00 gram per mole. The answer is 180.18 grams per mole. So 180.18 grams per mole, that's the molar mass of glucose. Okay, calculate the molar mass, number of moles, and number of particles present in 50.0 gram of iron oxide, or that's for us, no? Iron oxide is one of the reason for rusting of some metals. Okay? So this time, what we're going to do is to identify the number of molar mass, the molar mass of iron oxide, the number of moles, and the number of particles in a 50.0 gram of iron. Okay? So, identify natin yung moles at yung number of particles, or we can say molecules or atoms, in 50.0 gram of iron oxide. Okay? So, to get the number of moles, dapat alam natin yung molar mass ng iron oxide. So, para mahanap natin yung molar mass ng iron oxide, kasi gagamitin natin yung molar mass ng iron oxide para mahanap yung number of moles from the given 50.0 gram of iron oxide. So, let us first get the molar mass of iron oxide. In iron oxide, there is two elements. We have iron and oxygen. So, the number of atoms of iron in iron oxide is 2. The number of atoms of oxygen in iron oxide is 3. The atomic mass of iron is 55.85 grams per mole, and the atomic mass of oxygen. So, before we get the atomic mass, or we take a look at the atomic mass of oxygen, let us first multiply 2 times 55.85. So, why did we multiply 55.85? Because there are two atoms of iron in the molecule or the compound. So 55.85 times 2, or 2 times 55.85, the answer is 111.7 grams per mole. Okay? What's the atomic mass of oxygen based on the periodic table of elements? That is 16.00. So 16.00 times 3, the answer is 48.00 gram per mole. So we have to add this one. Okay, 111.7 plus 48.00, the answer is 159.7 gram per mole. So that's the molar mass of iron oxide. Okay, so continue. We already get the molar mass of the iron oxide. So the molar mass of iron oxide is based from our computation from the previous slide is at 159.7 gram per mole. That's the molar mass of iron oxide. It means that in every 1 mole of iron oxide, there is 159.7 gram of iron oxide. Okay? So let us continue. So since we get the number of the molar mass of that iron oxide, we can now compute for the number of moles, okay, of iron oxide in a given 50 grams of iron oxide. So 50 grams of iron oxide times in every 1 mole of iron oxide, okay, there is how many grams? There is 159.7 grams of iron oxide. Saan galing to ulit? Ito yung kinompute nating molar mass ng iron oxide. Okay, so Kasi the molar mass of iron oxide from our computation is 159.7 gram per mole. It means that in every 1 mole of iron oxide, there is 159.7 gram of iron oxide. Okay? So therefore, 50 grams of iron oxide times in every 1 mole of iron oxide, there is 159.7 grams of iron oxide. So, multiply, then divide. Para mabilis, divide na lang po. Kasi 1 lang naman yun. So, 50 divided by 159.7. Again, divide. 50 divided by 159.7. Okay? Cancel si gram. Matitira si mole dito. So, 50 divided by 159.7, the answer is 0.313 mole of iron oxide. So, meaning to say, in a 50 grams of iron oxide, there is 0.313 mole of iron oxide. Okay, is that all? Not yet. We already get the number of molar mass. The molar mass of iron oxide, check. Well, the number of moles, 0.313 mole of iron oxide, check. And the only thing or the only quantity left in this problem is the number of particles or the number of molecules or atoms, okay, from 50.0 gram of iron oxide. So we can now use this number of moles computed to get the number of particles. So 0.313 mole of iron oxide times in every 1 mole of iron oxide there is, okay, 6.022 times 10 raised to 23 atoms of iron oxide or particles of iron oxide. Okay, so what we're going to do is just multiply. Okay, multiply then divide sa 1. So, okay na kung hindi na i-divide sa 1. Okay, so just multiply 0.313 times 6.022 times 10 raised to 23 atoms. The answer is just cancel first the unit at mole. Ang matitira ay atoms or particles. Okay, so 0.313 times 6.022 times 10 raised to 23. The answer is 1.88 times 10 raised to 23 atoms or particles of iron oxide. So, we have already computed for the molar mass, the number of moles, and the number of particles present, okay, in 50.0 gram of iron oxide. Okay, so another example, how many grams are there in 4.5 moles of sodium fluoride? Okay, so just take a look in this example. Another example is this one. How many atoms is 20.0 gram of chlorine gas? So, the molar mass of chlorine gas is 70.90 grams per mole. Okay? Ito ay kinompute na natin. Kailangan mo natin i-compute to. So, itong 70.90, that's not given. We have to compute it. Okay? So, molar mass, ang na-compute na value is 70.90 grams per mole. So the given atoms is 20.0 grams. So 20.0 gram of chlorine gas to get the number of atoms. In every 1 mole of chlorine gas, there is how many mass? There is 70.90 grams of chlorine gas. Okay? Times, okay, just first cancel those given. So natira yung mole. Okay? Times. Para it is the direct, this is direct computation, ha? Times. In every 1 mole of chlorine gas, how many atoms? There is 6.022 times 10 raised to 23 molecules of chlorine gas. Ito yung mas pinaikli na lang na direct computation para makuha si atoms. Okay? So, what we're going to do is that 20 divided by 70.90 times 6.022 times 10 raised to 23? The answer is 1.70 times 10 raised to 23 atoms or molecules of chlorine gas. Okay? So, ang nang ginawa lang natin, direct na siya. Long computation para makuha agad si atoms. Another example, another example, thank you for your listening. If you have any more questions, don't hesitate to chat me. Okay, that's the end of our lesson for week 7. Have a nice day.